Welcome to the Deep Dive. Here at the Crypto Visionary Network, CVN, our mission, as always, is to cut through the noise, give you a real shortcut to being well-informed.
Yeah, get you up to speed quickly.
Exactly. Today, we're diving deep into Celestia. It's a crypto project that's been making, well, some serious waves.
It certainly has.
We've got a whole stack of sources here, technical docs, community chats, the works, and we're going to unpack it all. What makes Celestia unique? Where does it shine? And, where does it maybe stumble?
Sounds like a plan.
Okay, let's unpack this.
Absolutely. So Celestia, it's a really innovative approach, actually, in the crypto space, I mean. It's fundamentally changing how we think about building blockchains.
How so?
Well, at its heart, it's focused on creating a modular consensus and data availability layer.
Modular. Okay.
Yeah, the big idea here is to make dApps, decentralized applications, much more efficient and secure. And it does that by separating core functions, things that are normally bundled together in traditional blockchain designs.
Right. That separation seems key, especially for those of us maybe newer to this specific project. So fundamentally, what is Celestia and why is this modularity such a big deal?
That's the perfect place to start. So imagine most existing blockchains, right? Like Bitcoin or even older Ethereum versions. We call those monolithic.
Monolithic, like one big stone block.
Pretty much, yeah. Think of it like an old all-in-one printer. It prints, it scans, it copies, all in one box.
Convenient? Maybe.
But if one part slows down, the whole thing grinds to a halt.
Exactly.
These monolithic chains, they do everything. Making sure data is available, agreeing on transactions, running code, settling those transactions, all tightly integrated. And that becomes a massive bottleneck for scaling up.
Okay, I see the problem there.
Right. Celestia, though, it embraces a modular architecture. It's like breaking that printer into specialized devices. A dedicated printer, a dedicated scanner.
So each part can do its job better and faster?
Exactly. Each component scales independently, more efficiently.
Yeah.
Specifically, Celestia focuses only on providing those foundational layers. Data availability and consensus.
Just those two?
Primarily, yes. The actual running of applications, the smart contracts, that's handled by other specialized chains built on top of Celestia. Rollups, usually.
Interesting. And it has its own crypto, TIA.
It does, TIA. Launched with the mainnet October 31st, 2023. And it's really central to this whole ecosystem.
So TIA is more than just something you trade. What are its actual jobs in this modular setup?
Oh yeah, it's got several crucial roles. First, it's the fee for Celestia's data availability solutions. Developers pay to store data on Celestia in what's often called blob space, using TIA.
Blob space? Okay, like data blobs.
Yeah, think of them as big, efficient bundles of data. Second, for those rollups built on top, TIA is their gas token. They use it to pay for posting their transaction data back down to Celestia.
It makes sense.
And it's also vital for staking, securing the network by incentivizing validators. Plus, governance TIA holders get a say in the project's future.
Okay, that's clear. Now, this is where I found it gets really interesting reading through the material. Celestia introduced something called data availability sampling, or DAS. Now, for listeners maybe not deep in the tech weeds, how does DAS work? What makes it such a big deal?
DAS, yeah, that's kind of the magic sauce. Traditionally, right, to be absolutely sure all the transaction data in a block is actually available, not hidden or messed with, you need to download the entire block.
Which gets bigger and bigger.
Exactly. As blocks get huge, especially with these ambitious scaling goals, downloading full blocks just isn't practical for most users. It pushes decentralization towards only those who can run powerful full nodes.
Right, centralization risk.
Precisely. DAS changes this. It lets even low-powered devices like your phone or just a web browser verify data availability without downloading the whole block. Instead, they just sample random chunks of data from the block. They pull a few pieces here and there. As they get more samples, they calculate a confidence score.
Ah, so the more samples, the more confident you are the whole thing's okay.
Exactly. It's almost like tasting a few spoonfuls of soup to know if the whole pot is good. You don't need to eat the whole pot.
So wait, my phone could actually verify a massive block just by sampling. That is fascinating. Feels like a real shift in blockchain security, accessibility. Are there trade-offs, though? Any complexities with DAS? Security guarantees?
That's a sharp question. Yeah, there are considerations. The security of DAS relies on having enough different light clients doing these random samples. The more ice sampling, the stronger the guarantee.
Shrink the numbers.
Exactly. For instance, on Avail DA, which is a similar project using DAS, you can get close to 100% confidence with just 8 to 30 samples, which is incredibly efficient. The big benefit is You reduce reliance on those powerful full nodes. It empowers end users, regular people, to independently check data availability. That's huge for decentralization. You don't need a supercomputer anymore.
So both Celestia and this Avail DA use DAS.
They do. They leverage DAS to build this peer-to-peer network of light clients that can collaboratively support much larger blocks. And there's a related technique, erasure coding, which adds redundancy to the data, makes it possible to rebuild data even if parts are missing. Celestia supports that too, helps make DAS possible.
Okay, so given this modular design and the power of DAS, let's talk numbers. Performance. Throughput, scalability, critical stuff for adoption, right? How does Celestia stack up?
Right, the metrics. Currently, Celestia's mainnet is doing about 8 megabytes per block, but the design itself has a hard-coded limit way higher, 100 megabytes per block.
Whoa, that's like 12 times more.
Yeah, 12.5x potential improvement built in. And their ambition, the real goal they talk about, is gigabyte-sized blocks eventually.
Yeah, like gigabytes compared to what? What's Ethereum doing now?
Good comparison. Ethereum, even with its recent proto-dank sharding upgrade, which adds those cheap data blobs, is currently doing about 8.2 megabytes per block. Their future goal is aiming for maybe 16 megabytes.
So Celestia is aiming potentially much, much higher on capacity. What about speed? Block times, finality. How fast is it settled?
Celestia creates and finalizes its own blocks very quickly, just 6 seconds. Snappy. However, for what we call data availability finality, being absolutely sure the data is there and fraud proofs can be processed, that takes about 10 minutes.
Why the delay?
It uses fraud proofs. Transactions are assumed valid unless someone proves otherwise within a challenge period. That challenge window adds the time.
Okay. Innocent until proven guilty, basically.
Kind of, yeah. Compare that to, say, a Avail DA. Using validity proofs where things are proven correct up front, they can get DA finality in about 40 seconds. Much faster. Ethereum's data finality, for comparison, is around 15 minutes.
Got it. And the cost, that's always a huge factor for devs. I saw something that's super blob. Sounds cool.
Yeah, super blobs. This is where Celestia really shines on cost. Conduit, a big rollup provider, did research showing that historically posting data to Celestia was like 64% cheaper than Ethereum blobs, around $7.31 per megabyte versus over $20 for Ethereum.
That's already a big saving.
But yeah, super blobs. Conduit and Celestia teamed up. These are optimized data bundles, even bigger, more efficient batches, up to 1.8 megabytes, way bigger than Ethereum blobs can handle.
Yeah, and the cost impact.
This is the kicker. Super blobs can achieve a staggering 96% reduction in settlement costs compared to Ethereum blobs, bringing it down to just $0.81 per megabyte.
Yeah. Okay, 96% reduction. That's
Yeah.
That's monumental. Forget just saving money. What does that actually unlock for developers? What kinds of apps become possible now?
Exactly the right question. It's not just cheaper, it changes the whole game for rollups. Because they can post fewer, much larger super blobs for the same data, they save enormously on gas fees. They don't need to settle back to Ethereum nearly as often.
Right.
This fundamentally alters the rollup business model. It makes things like custom gas tokens for specific apps way more viable, which is better for users. And crucially, it massively boosts transaction capacity. More users, higher TPS. It opens the door for really data-heavy stuff that was just too expensive before.
Like what? What kind of data-heavy stuff?
Think fully on-chain social networks or complex games where every single action is recorded on-chain because the data cost is finally low enough. Stuff that was just a pipe dream on monolithic chains.
Okay, the potential sounds huge, but crypto's rarely smooth sailing. Even with cool tech, there are always challenges, debates. What criticisms or hurdles has Celestia faced, especially around the TIA token price and market perception?
You're right to bring that up. TIA's price has definitely been a hot topic. It peaked around $21 early 2024, then saw a pretty sharp fall later that year and into 2025. There were real risks of wiping out gains from late 2023 and early 2024.
Yeah, I remember seeing headlines about a death spiral. What was driving that?
Part of that narrative, was linked to a series of token unlocks. The plan involves significant amounts of TIA becoming available over time, like 40% of tokens unlocking by 2027. So there are concerns about market absorption. Can the price hold up with that much new supply hitting?
And I've also heard that term VC chain thrown around. What's that about? Sounds like criticism about who owns the tokens.
That's a big one. The VC chain label comes from allegations about, predatory unlock schedules that heavily favor early venture capitalists. Critics point out that some early investors made huge returns, even with the price drops, raising questions about fairness and alignment with, the decentralized ideal.
That classic crypto tension, funding innovation versus fair distribution.
Exactly.
Yeah.
How do you get the big money needed to build something complex without making the community feel like insiders are just waiting to dump? Plus, some observers feel there's been a gap between Celestia's vision and current traction. A sense that Celestia's been maybe selling a dream that's taking too long to materialize for some, waiting for those killer apps.
That's quite a bit to unpack there. How do Celestia supporters or the team itself usually respond to those points, especially the VC thing or the vision versus traction gap?
Well, proponents usually argue that, look, you need that early investment to fund the massive R&D for this kind of infrastructure. It's complex stuff. They'd point to the long-term vision, the developer activity we'll talk about, as proof the dream is happening, just maybe not on the hyperspeed timeline the Musket sometimes demands.
It's a marathon, not a sprint kind of argument.
Pretty much. And that this modular approach is a whole new paradigm. It takes time for devs to really figure it out and build on it. But yeah, to put it all in context, let's compare Celestia to other DA solutions, especially thinking about decentralization.
Great idea. How does it stack up against, say, Eigenday? I hear that name a lot, too.
Right, Eigenday. It's quite different, actually. It's a data availability, a day A, not really a public blockchain itself.
Okay, what's the difference?
It means it can hit higher throughput, they claim 15 megabytes per second, because it doesn't have the same strict verification rules as the blockchain. But, and this is key, that introduces trust assumptions.
Meaning you have to trust the committee more?
Basically, yeah. It can't publicly verify data availability in the same trustless way. It relies on economic guarantees slashing if they mess up, and it has a known centralized component, the disperser, that handles data distribution.
Interesting trade-off. And Ethereum itself, as the big incumbent.
Ethereum, well, it currently has the lowest data throughput of these main options. That limitation is why solutions like Celestia and Eigenade emerged, right? The market saw Ethereum couldn't handle all the data needed for a roll-up heavy future on its own layer one.
Got it. So what about decentralization? We talked about the VC concerns. How do they compare using something like the Nakamoto coefficient? Maybe quickly explain what that is.
Sure. The Nakamoto coefficient is basically the minimum number of entities, could be validators, stakers, whatever needed to collude to potentially disrupt or control the chain. Higher number is generally better, means more decentralized.
Okay, makes sense. So,
Well, Ethereum, even with its million-plus validators, actually has a very low Nakamoto coefficient because so much stake is concentrated with big players like Lido and Coinbase.
really? That's surprising.
Yeah. Celestia uses delegated proof of stake, PPOS. Token holders delegate to validators. This model is generally seen as more prone to validator centralization risks. Its Nakamoto coefficient is currently 6 out of about 100 validators.
Only 6 entities needed to collude.
It's a point of discussion, definitely. AvailDA, for contrast, uses nominated proof of stake, NPOS, and aims for a very high Nakamoto coefficient by trying to spread stake more evenly. They hope to go to 1,000 validators eventually. So different approaches, different decentralization profiles.
That really clarifies the trade-offs. Okay, despite market swings in these debates, you mentioned the ecosystem seems really active, lots of building going on. What stands out?
Yeah, the developer activity is genuinely impressive. They have this big online hackathon, Mammothon, over 3,900 builders, 100-plus projects submitted. It really showcased people building fundamentally new kinds of apps using Celestia.
Cool. Any specific examples from Mammothon that really show off what Celestia enables, like using that cheap data or modularity?
Absolutely. One I thought was neat was Evolute. It's an on-chain strategy game, like territorial conquest. The key is every single move is a smart contract execution recorded on-chain.
That must generate a ton of data.
Exactly. Doing that on a monolithic chain would be insanely expensive, maybe impossible. Celestia's cheap DA makes it feasible. Another cool one, ZK Media. It's an image editor using zero-knowledge proofs.
Zero knowledge, meaning privacy.
Right. You can prove an image is authentic or prove edits were made without revealing private data about the image itself. Again, needs cheap, verifiable data storage, which Celestia provides. Oh, and for fun, Hakachi, basically an on-chain Tamagotchi pet. Every interaction recorded forever turns a game into a permanent digital thing.
Huh. An on-chain Tamagotchi. Okay, that's pretty niche, but definitely shows the possibilities.
Yeah.
Beyond hackathons, any bigger partnerships or frameworks using Celestia? Wider ecosystem stuff.
Definitely seeing broader adoption. For instance, there are ZK rollups being built on Bitcoin now, using Celestia for their data availability. That's a really interesting cross-chain play.
Bitcoin rollups using Celestia DA. Wow.
Yeah. Also, the Kinto Exchange integrated Celestia for DA. Initia, which is a framework to make launching rollups easier, uses TIA for DA, lowering the barrier for new chains.
So making it easier to build on Celestia.
Exactly. And Pay Network, they're using Celestia for their CK Validium rollup to boost scale and speed, plus Abundance, another rollup framework, and Derive, a derivatives protocol, both using Celestia as their DA layer. So yeah, lots of projects actively building and integrating.
Okay, the ecosystem seems genuinely busy then. And for regular folks holding TIA, how can they get involved? Staking.
Yeah, staking is the main way. TIA holders can stake their tokens, use a wallet like Coupler, for example, help secure the network, you earn rewards. Just got to remember there's that 21-day unstaking lockup period. Your tokens aren't instantly liquid if you decide to unstake.
Good practical tip.
Right. And before we wrap up this deep dive, we really need to remind you of something important.
Absolutely. The information we've shared today, it was gathered from lots of different internet sources, compiled using AI. We always aim for accuracy, apply common sense, but, mistakes can happen. Misinformation is out there. Nothing we've said here should be taken as financial advice. Seriously.
Yeah, this is purely for education, maybe some entertainment, learning together.
Exactly. You should always do your own research. Use your own judgment. Apply common sense to any financial decisions you make. Please.
Couldn't agree more.
So, after all that, what's the big takeaway on Celestia for you, our listener?
Well, it's bold bet on modularity, that data availability sampling innovation. It really does challenge the old way of doing blockchain.
It really pushes the boundaries.
Yeah, it paints a picture of a future where building complex, high-volume dApps could become way more accessible, much cheaper than before. It might unlock totally new things for the digital world.
Opens up possibilities.
It really makes you wonder, right? Is the future monolithic chains trying to do it all? Or is it this constellation, maybe, of specialized, interconnected modular layers, each doing one thing really, really well? Something to think about.
Definitely food for thought.
We really encourage you to keep exploring these modular blockchains yourself. Check out the apps being built. See what you think.